All right, this is part 2 for section 1, still talking about forces and motion. Now we're going to look at how to draw these force diagrams, which are also called free body diagrams. So, our goal here is just for you to interpret and construct free body diagrams so you understand what they're telling us and how you can make your own, so we can understand what is happening in forces better. So, there are several rules to follow when drawing force diagrams. First, there's only one object per diagram. So for example, we'll look at this example specifically in a second, okay? If you have a book sitting on some table, okay, we don't need to draw both the book and the table. If we're talking about the forces acting on our book, we would only draw the forces on our book and only draw our book. We don't need to draw the table. Next is a force vector always points in the direction of the force. So for example, looking at our book again, okay, the force of gravity is pulling it towards the ground, so the arrow needs to be pointing towards the ground. Next, we assume that forces always act through the center of an object, okay, and if you want to know why, honestly, you have to take calculus, but anytime we have anything where it's a book with a force through it, if it's a person, I'm just going to draw them as a ball, we've got a force, all the forces always come through the center of the object, okay. Next rule is just that the tail of a vector is always at the center of the object. So I was drawing it this way, but maybe you noticed. When I say that force of gravity is going down, I would not draw it like this, okay? That is incorrect, okay? Because the tail, remember this is the tail of a vector, it's not in the center of the object, right? It's up here instead of being here. To correctly draw the force of gravity acting on our book, we would draw our book, and then we would have the tail of the vector start in the center and the arrow come down. So this would be our correct way to draw the force of gravity acting on our book. So now let's take a look at some examples of how we might do this. Our first example is the one we were just talking about. A book is at rest on a tabletop. So I only draw my book, okay? I know it's sitting on a table though. It looks like it's in midair, but it's actually sitting on a table, okay? So there's my book. And I'm going to have the force of gravity acting. It's pulling the book down. And one thing that isn't on the rules, but that we need to do, is we should always label our vectors, because often more than one force is acting on something. So I'm going to write a big capital F for force, and a little g, meaning it's the force of gravity. Okay. The next thing we need to do is there's one more force acting on this, okay? So we know that there's a table here that it's sitting on, and the book isn't falling down, so we know that that table is actually pushing up on the book. It's holding it up so that gravity doesn't pull it down. So we also need to add the force of our table, okay? So I also need to name this one, and I could call it the force of the table. And later we will learn that anything opposite of gravity, right? So this force is acting in opposite to gravity, and it's perpendicular to where the table sits, okay? This is also called a normal force. We will look more at this later, okay? But often you will see this, instead of written as force of the table with a T, you'll often see it written Fn because it's our normal force, okay? Let's look at another example. Now I've got a girl hanging motionless from a bar that hangs from the ceiling by 2 ropes, okay? So what that means is I have a bar and there's a couple ropes, and then hanging on it is some girl, okay? So that's not my free body diagram. That's just I want you to understand what's going on. So in this, okay, I'm going to draw a free body diagram, and it's just of the forces acting on my girl. So I'm just going to draw my girl. Your picture doesn't have to be perfect, okay? If you wanted, you could even just draw it as a big circle and label it girl, okay? And accuracy of our picture of the object isn't that important. What we do want to draw accurately is our forces, okay? So whether I'm drawing a person or a blob, we know that the force of gravity is pulling down on her, so I draw it from the center. And I draw a force of gravity. Okay. Now remember, the length of the arrow matches the magnitude of it. So my two arrows here, since they're the same thing, should be about the same. Okay. And then, because over here there's two ropes on this bar that she's holding on, we're going to draw these two forces separately coming up at a little bit of angles. Okay. And they also come from the center, and they're equal. So I would draw them both like that, okay? Maybe we'll say the force of the rope in this case. And we can label them all the same thing because they're all equal forces. Okay. And because she's not moving, these two should be similar in length because they're the same force. And together, they oppose this force. And we'll talk more about that later. But their lengths should be roughly the same. So that would be our free body diagram of our girl. We're going to look at one more example here. This time we have an egg that's free falling from a nest in a tree, which is very sad for the egg, right? Because we know it's going to break. So we're going to start with our egg. An egg really does look like a blob, so it saves those of us who can't draw. Okay? And it's falling. So we know that the force of gravity is acting on this egg. But now we have to ask ourselves, are there any other forces? Okay. In the instructions here, it says neglect air resistance. So we don't need to add the force of air resistance here, which is why I'm not actually drawing it. And there's nothing holding the egg up. It's free falling through air. So it turns out the only force acting on it here is the force of gravity. So with just this, our free body diagram is done. We will, of course, do more practice with this in class. But hopefully now you have an idea of what we'll be doing and how free body diagrams work.